Thank you so much for joining us tonight. I'm Joyce Lights, Executive Director of Connecticut Audubon Society. And before we start, I'll do my usual housekeeping rules. You will be muted this evening. We are asking you to put your questions in the chat. Shannon's going to try and address them if it's really relevant to the point of the conversation. But if not, definitely we'll be addressing questions at the end of the presentation. For your best viewing experience, we recommend speaker view, which you're going to find in the upper right-hand corner of your screen. And the chat, of course, you're going to find in the pop-up button on the bottom of the screen. Thank you so much for joining us tonight. We know that you have a lot of options. There are a lot of video and webinar programs that are going on. But tonight, we're really happy to have Shannon joining us to have a conversation around the impacts of offshore wind and how we can address those to reduce the impacts on birds. She's been doing her research on this. Shannon is an adjunct lecturer at Stony Brook University. I'm very familiar with Stony Brook, by the way, Shannon. I actually used to work down in Stony Brook early in my career. And I just want to remind everybody that this is Young, Gifted, and Wild. This is our second of the series. It's a 4-part series. Our next episode will be on February 26th, where we'll be talking about impacts on ospreys. And then on March 5th, we'll have our final with Joanna Harvey of the University of Rhode Island talking about avian flu and its effect on the populations. And we certainly hope that you'll be able to join us for those as well. But right now, I'd like to welcome Shannon and invite her to say a few words about her background and talk more about her research. And I'm really looking forward to this conversation. Thank you.
Thank you. Thank you so much, Joyce and Tom, and thank you for having me for Young, Gifted, Wild About Birds. So yes, my name is Shannon Curley. I am an adjunct lecturer at Stony Brook University, but the work I'm going to be talking about is where I did my postdoc at the Cornell Lab of Ornithology, where I used weather surveillance radar to look at bird migration offshore. And before I begin, let me just get my screen shared here. Hold on. And do a little cleanup on the screen so I don't have to see my face here. Hold on. And now I see meetings. Sorry. Are we seeing my calendar or my
I'm
PowerPoint?
seeing something that says continue to share the PowerPoint window. There you go.
Okay. Sorry, a whole bunch of windows popped up while I tried to do that. Okay. So the work I'm going to be presenting is about offshore wind and bird conservation and the applications about conservation in terms of offshore wind and this research. And I just want to give a lot of credit to my co-authors here on the paper, Andrew Farnsworth, Timothy P. White from the Bureau of Ocean Energy Management, Judy Shimon Baranes from the University of Amsterdam, and Adrian Doctor, who has worked quite closely with me as I'm learning radar, because as you see, it gets a little complicated at times. But when we think about offshore wind and conservation in general, um, I also want to think about how we study wildlife movements in general. So it's not just about offshore wind. These movements are happening irregardless of whether offshore wind is there or not. So I hope that this work is also applicable to things like offshore drilling and gas, things like cruise ships, and any kind of development that we're doing offshore. And now I'm frozen. I am sorry. So just to give a little overview of the talk today, I'm going to give you a little bit of an introduction about bird migration. I know a lot of us here are probably familiar with birds, but also the challenges of studying birds at night. So mainly this talk is going to focus on nocturnal bird migration. And then I want to talk about human impacts and anything that we do to modify the environment. How does that impact the wildlife that's around us? And then specifically focus on using weather surveillance radar as a tool to study offshore bird migration on these broad geographic scales. And in our recent study, what we did is compare terrestrial and offshore migration, because that gave us a baseline, or gives us a baseline, and a comparison between how these movements differ So, how we can target and pinpoint different strategies that will help best in mitigation and conservation. And then, if I have time, because this is kind of loaded, we have expanded this research into Canada where this radar data was not available until very recently. So I hope I get to that, but somebody cut me off if I'm going too long here. So of the about 650 species that breed in North America, about half of them are migratory birds, meaning that they're moving from their wintering and breeding grounds each year. So what you're seeing here is this figure produced by the Cornell Lab of Ornithology with the eBird and BirdFlow team, which is a step-by-step movement using this eBird data to look at bird migration. And you can see it's quite a large spectacle. You can see a lot of different species that we have presented here. But when you think about the behavior of migration and the hundreds of millions of years in which this behavior evolved, it's only very recently that birds have had to encounter what you're seeing here, these bright spots of artificial light at night. Birds historically have not had to interact with humans on this kind of level. And that's kind of what I want to point out. So when we look at migration, we just saw that beautiful movie, but what does this actually look like at night? Well, I've been studying bird migration for 15 years, and it wasn't until 2023 where Zeiss gave me the opportunity to use a thermal imaging camera to look at bird migration. And I was just floored by how, to me, this was very unexpected. What you're seeing here, every little white orb flying, is a bird. They look like snowflakes floating in the wind. Now, these are birds off of Jamaica Bay in Queens. This is on the south shore of Long Island. And these birds are moving south-southwest during their fall migration. And you can see in the corner here that it's just, I never thought of seeing loosely aggregated birds just flying like this. But I was really just taken back by this. But if I forward, oh, there we go. I was also by JFK Airport. And as I'm looking at this, I'm like, wow, we really do share the airspace with animals, and everything that we do in our day-to-day lives, we do have this ability to impact wildlife ourselves. So this was just a video that really made me think and really just took me back on why I went into studying migratory birds. But I want to highlight something a little different. Now take a look, the flow here, the birds, they look calm, they're moving in a similar direction. Their flight paths seem pretty relatively steady. But I want to compare this to the 9/11 tribute in light. So each year on the anniversary of the attacks on the Twin Towers, there's an art installation that has two large beams of light, very intense beams of light, that shoot directly up into the sky. And the New York City Bird Alliance each year monitors these birds. And let me just play. Most of what you're seeing here are birds that become trapped in these light beams. Similar to the way moths get attracted to light, birds also, as they're migrating, also get attracted to these artificial lights. And this is a very extreme example. And what you're seeing is birds not going in a similar flight direction. They're quite frantic. If you're sitting there monitoring on the roof, which I have the privilege to do, you hear a lot of flight calls. And you can see how this is vastly different from the previous slide. But we are fortunate that we can talk to the production team, and when there's too many birds trapped in the lights, we have the opportunity to ask them to shut down the lights for a couple minutes to let these birds travel on their way. And this is really important because when you think of a migratory bird that's traveling from, say, Canada to Central or South America or to the Caribbean islands, and you only weigh several grams, this is a lot of energy to waste in a short amount of time, and this can mean life or death for a bird. But what I want to show you is once we shut down the beams, I'm going to fast forward just a minute and a half here, the sky becomes completely empty. And the reason why I want to show these two slides together, the ones of what we see with standard migration and what we see with human impacts, is that we do have the ability to mitigate the impacts on wildlife, whether it's something as intense as this or something as simple as curtailing a wind turbine. So that's why I wanted to point that out. Now, as a daughter of a 9/11 firefighter, I see the huge importance and symbolism in the 9/11 tribute. And it's a huge honor for me to be able to be that person that gets to be there to help monitor. And just a shout out to New York City Audubon and the volunteers that do this every year because they are there from 7 at night till 7 in the morning. And it's a long day. But as you can imagine, so this is with a thermal imaging camera, it's still difficult to study nocturnal bird migration. Visual observations are very difficult, sometimes nearly impossible, and this really depends on weather conditions, whether it's how much moonlight you have, the cloud cover, the weather. Anything can really obscure detection. Additionally, migration occurs over large continental scales. And we have really nice tools like radio telemetry, GPS tags, but this also requires a lot of infrastructure. It requires a lot of funding. For any of us in research, funding is key, and also the ability to process this large quantity of data. So consequently, temporal coverage can be inconsistent, and standardizing these methods of studying bird migration can be very challenging over time. However, we do have a nice tool that allows us to look at bird migration at these large continental scales. Now, I'm not sure if any of us have seen a weather radar before. This is a NexRad, meaning next generation weather radar. There's about 160 of them operational across the United States, and they are dual polarized, meaning that the radar wave that shoots out of the radar itself, dual meaning two, we have a vertical wave and a horizontal wave. So both of them allow incongruency, allow us to detect the shape of an object. It allows us to distinguish something as different as precipitation from a bird, looking at its symmetry. So when a radar scans, it scans at a couple different elevational levels, making what's called a polar volume. And think of that as like an orb. And so we get a lot of information about birds based on, and weather, based on these radar waves that go out. They hit an object, that energy is returned, and that's processed. And that's in the terms of what we call reflectivity. And reflectivity can be converted into a density. So that's where we're getting this measure of birds from. So what you're seeing on this on the screen here is what bird migration looks like across these radars. It looks like a bloom at each one of, you can see here, each one of these radars looks like a bloom, and you can see this pattern that runs from east to west, and that has to do with sunset. So as birds take off, it's usually about 3 hours after sunset is where we see peak migration, but they look like a bloom because as the radars are scanning about every 6 to 12 minutes, what you're capturing is these birds rising into the air column. So that's why it kind of looks like a bloom. And some of the darker colors you see here, these greenish and more intense yellows, that is actually precipitation. So radar does a nice job and has a lot of coverage across the United States to look at these patterns over time. So I work with a team. Maybe some of us are familiar with Birdcast, and this is a collaborative effort of aeroecologists, and these are avian ecologists, computer scientists, just some of these most brilliant minds that I just so much enjoy working with. And it's a big collaboration that's still growing. So here we have the Cornell Lab of Ornithology, where I did my postdoc, Colorado State University, and the University of Massachusetts Amherst, and still continuing to grow. And what is Birdcast? Well, as I said, it's these scientists and researchers that specialize in aeroecology, which is the study of birds and biology, things like insects, bats, um, in the aerosphere. And what the goal of Birdcast is to make these real-time predictions of avian migration and using weather surveillance radar and tracking these bird movements through spring and fall. And the goal is to engage as many people as possible to be interested in birds, whether it's from bird watchers, researchers, conservationists, and trying to make this data open access and easily available to everybody. And what's great about Birdcast, and there's a new website, the website's going to be updated March 1st, so you'll see a whole new kind of platform, but it aims to look at these bird migration patterns on these larger geographic scales, be able to aim the timing of things like lights out. So these are a lot of programs in big cities where we say, if you can, shut down your lights to prevent birds from colliding with buildings or interacting with artificial light at night. And the long-term data sets have a lot of implications for climate and anthropogenic change of these patterns. And I just wanted to highlight here on October 6, 2023, this was Birdcast's first billion bird night. So this is a really intense migration night that was captured. And I'll just quickly, for those of who may not be familiar, Birdcast has, I won't go through the website, but if you go to birdcast.info, you will get a series of tools that you can look at. And here I'm giving an example of a 3-day migration forecast. So it's very similar to like a weather forecast, but it's where and when are the birds going to be most intense in migrating. I guess I could quickly go through. Let's just look at Queens County just to humor myself on the day that I showed us the footage of bird migration. If it doesn't load, I'll move on with the talk. So the night I showed you from my original thermal imaging camera, if you go to Birdcast, you can plug in the county that you're in or the state that you're in, and you can get all sorts of metrics about migration that night. It will tell you how many birds were in flight during the course of the evening. It will go through the season and show you all those peaks and valleys of migration when we had the most intense migration, flight direction and speed, the number of birds crossed throughout the season, and even flight altitude. So I won't go too much into this, but there's a lot of things to explore on this website if you're super interested in learning more about birds and nocturnal bird migration. So what I do want to point out is we know that each year billions of birds are embarking on these migratory journeys. There's a high seasonality that's to it. You can see that in spring migration going through the United States, we have fewer birds migrating up in the spring, but we see more birds migrating down in the fall. And that's because when birds come to breed, there's more young that are produced, and that inherently increases the number of birds that are going to migrate south. Most of what we know is on land. But we know that oceans cover about 70% of Earth's surface, but studying birds over the open water is challenging. So now it's not just challenging studying nocturnal birds, but now over the water presents its own challenges because it's obviously more remote, it's not easily accessible, and there really isn't a ton and very limited infrastructure for monitoring birds offshore. And the goal of our study was to look at the Gulf of Mexico and the Atlantic coast and get as much information as we can because there's a lot of overlapping areas where wind and energy development is occurring. So while we don't know a lot about offshore migration, these are photos from a friend of mine, Allison Black. She is a seabird scientist with NOAA, and she sent me these photos to see the huge diversity of birds that are actually found and land on the ships when she's working offshore. Things like black Burnian warbler, northern parula, black-throated warbler, uh, northern water thrush, bay-breasted warbler, American redstart, and not a warbler, but I love them, white-throated sparrows. There's quite a bit of diversity of birds that are migrating offshore. You can tell that some of these are also adult birds. And I'm going to play a video, so I just want to warn, I think I shared the sound. If I didn't, I suppose it's okay. I might have forgotten. Should I reshare quickly just to make sure?
That's fine with me, sure.
Fine.
Okay. Hold on. I'm sorry. I think I forgot to do that, even though we said to do that. It was shared. Okay. My apologies. There's a little bit of sound that's going to play on this slide, and I don't want to scare any of us because it starts with wind blowing, and sometimes that might scare us while we're getting the sound going. But what you're looking at is a fallout event that's occurring in the south of and what's happening is the birds are encountering a headwind flying on the floor. There's neck lights on, and unfortunately, during visibility are now gone. Here's the light calls, the wind, the puppy warbler, yellow warbler, warbler. Were you able to hear me through the sound?
We couldn't hear you for the sound.
Okay, so I will just repeat what we, sorry, what we just saw. This was a fallout event that occurred on the 10th of August in 2020 in the southwestern Gulf of Mexico. And what you're seeing is this is off of a NOAA ship that was doing research, and there was very low visibility that night. And what happened was there was a bit of a convection event, and the birds hit, apparently, they had hit a headwind as they were migrating and got attracted to the deck ship lights. So, what you're seeing is a lot of birds that are very frantic, that are disoriented, that are traveling over the water due to a weather event. And this is significant. We call these fallout events, but we know that there's a tremendous amount of bird migration happening, but we haven't yet quantified it on these larger geographic scales. And up until recently, offshore wind development was predicted to increase in the future. What you're seeing here in blue and yellow on this figure here on the right are the areas where the planning and lease areas for offshore wind. And the idea of this work with the Bureau of Ocean Energy Management is we want to know were these areas significantly overlapping with bird migration patterns? And we know these movements are understudied. And we know that any type of infrastructure that is developed can potentially impact birds, especially when you think about birds that are migrating at night where conditions are um, challenging, where there's low visibility, where the weather is not great. And so our study wanted to know when, where, and how many birds are flying offshore, and particularly at low altitudes. And we wanted to compare terrestrial and offshore habitats, and these are adjacent habitats. So we looked at one radar and we looked at what's happening on land versus what's happening over water. Because if we can parse those differences in migratory behavior and kind of isolate differences between the two, it gives us a better idea about how to target and implement most effective migratory or most effective conservation strategies. Now, I will say I am just the data collector. I am not the person who gets to make those strategies. So, what I'm going to be presenting here is strictly the data. But the goal behind it was to think about ways that we can implement dynamic conservation strategies, things like curtailment, forecasting, and real-time alerts to let wind farm operators know when would it be a good time to shut down the turbines. Particularly if birds are flying low within the rotor swept zone, which would be where the blades are located, which is typically under 300 meters. Now, also research and time and shutting down turbines cost a lot of money. So the idea is if we find differences like migration periods are shorter over the course of a season or occur on fewer peak nights, then maybe this might be optimal and maybe it will reduce the operational downtime for offshore wind. So our study was recently published in the Journal of Applied Ecology, and it's called Differences Between Terrestrial and Offshore Bird Migrations, Implications for Offshore Wind Energy. And what you're going to see for the next few results is everything in purple, these four radars here, and you can see the four-letter acronyms for each one of these radars. Is the North Atlantic in purple, the Mid-Atlantic in blue, the Eastern Gulf of Mexico, these three radars in green, and then the Western Gulf of Mexico in yellow. And we looked at five different metrics. One was the seasonal passage of birds, and that involves essentially a transect line and taking those densities. Remember when I said reflectivity can be converted into bird density? Well, within a 1 kilometer line, we count how many birds based on their density have passed that 1 kilometer in a given period of time. We also want to know something about the orientation of a coastline. So think about bird migration depending on the season, whether it's north to south in the fall or south to north in the spring. And you think of this bar here as a coastline. If birds are running parallel with it, it's essentially what I call, and I think we now all call it in the lab, hugging the coastline. So you could think about it the other way too. If we see birds going perpendicular to a coastline. So think about the Gulf of Mexico and birds, let's just say they're migrating south and they cross over into the water. That's essentially a metric that we're looking at to look at the proportional change of offshore migration from spring to fall. We also want to look at the duration of migration. And we do this by taking that passage that I mentioned, the number of birds, and we partition it into the 5 and 95 percentile, meaning what is the day of the year where 5% of migration occurs up until the day of 95% of the migration occurs in the unit of consecutive days or consecutive nights here. But then we have this moving window in between that we call peak migration. That's when 25 to 75% of migration occurred in the number of consecutive nights. But when I showed you the Birdcast website earlier, migration doesn't occur evenly across the season. It occurs on peak number of nights. As you can see here through March through June, through a hypothetical example, peak nights, this is migration traffic. You can see that migration isn't the same throughout the season. So we did a similar thing. We looked at how many nights did it take to get to 50% of our migration threshold at that radar versus 90% of the migration at that radar. And lastly, we want to look at the differences in altitude between land and offshore to give us an idea is how many birds are at threat or would encounter and fly below the altitudes of a rotor swept zone. So the methods can get a little daunting, so I'm happy to explain this afterwards, but I'll go a little bit quickly here. Again, we had the 16 NEXRAD radars from 2014 to 2023, so we were lucky to have a nice 10-year data set to look at. We considered spring, March through June 15th, and fall from August to November 15th. And this data, you can actually go on Amazon Web Services and you can go right in and download these polar volumes, like I mentioned, each scan from a radar. You can go and download for free. It's a very large amount of data, though, and I wouldn't recommend it unless you had a hard drive or something. I made a bit of a mistake this week and almost crashed my computer with new data, but that's not here nor there. It's free to download and it is accessible, and there are tools that you can look at this without downloading anything, and I'm happy to share that after the talk. And what we did is we created spatial masks. So if a radar is sitting here, right here in New Jersey, we create a mask where I take that polar volume. Again, I said it looks like an orb. Um, and I look at that polar volume and I take the geography and I parse out what's land and what's water. I put a 5 kilometer buffer just so we don't conflate or don't mix up the differences in behavior between land and water. And so for every polar volume, we have a scan that looks just at land and then just at water. And what you're seeing here is we calculate what's called a vertical profile. And really what that is it's taking all those scans from the polar volume and we're looking at bird density, what you're seeing on the x-axis here, against height in the atmosphere up to 5 kilometers. So we kind of stack that polar volume, we look at bird densities, and this is just a graph of what the density is, here being 0, here being almost 200. And what you see with this pattern here is that bird densities and bird migration really occurs quite low. And in fact, the bulk of bird migration occurs below 1 kilometer. So I feel like a lot of people, when I tell them that, they're like, really? You don't believe me? But I promise you, if you go to a quiet space on a night where there's migration, you will hear those birds and some flight calls over your head. So migration actually occurs quite low. But one of the problems that we have to address in studying bird migration offshore is that as a radar beam moves away from the radar, because of the curvature of the Earth, you can see the curve here. Unless you believe in flat Earth, I hope we don't. But because of this, what you see is a radar beam, it starts to broaden as it travels away from the radar. But also because of the curvature of the Earth, it starts missing this gap of activity. And that's a problem offshore, particularly because on land, we don't typically see that missing gap. And that's what we're seeing below 300 meters here. But as I mentioned from the previous slide, a lot of bird migration occurs below a kilometer, below 1,000 meters. So what you're looking at here is a stitched together vertical profile from a radar at night that goes from midnight to about 6 in the morning. And these cooler colors are intense bird densities, and these lighter colors are less. So the same pattern, high migration at lower altitudes, and it kind of peters off and is less dense overnight. Well, the problem here is that birds don't just look at 300 meters as they're flying and be like, nope, I'm not going to fly there. What we know is that the radar offshore is missing quite a bit of migration activity. So, what we had to do, what I had to do was develop an altitude extrapolation model. So, basically, taking what we know about the upper part of the atmosphere and these typical migration patterns to predict what's happening below. And I won't go into the machine learning details here, but it involved a lot of transforms and training on over 700,000 profiles to train these models. And but basically what this model is doing, it's taking everything, like I said, what we know from above and predicting what's happening below. So here's our missing prediction offshore for one of the radars that's missing 300 meters. And here's what our model did. Our model filled this in to give us another estimate of birds to fill in that gap that's missing. And in fact, just in this example alone for one night in 6 hours, if we did not take this extra step, we would have missed 300,000 birds that migrated past that radar that night offshore. So it was a tough step, but a necessary step that we needed to do. And one of the reasons why we had not yet extended our forecasting from birdcast to the offshore habitat. And this is just an example of how this model performs over the course of several days. So you can see we're filling in the gaps and we're filling in the migration that was missing. So just some results. Offshore migration was typically lower than onshore or terrestrial migration. And what you're seeing here, we have our different groups. Remember the the Western Gulf of Mexico, all the way to the North Atlantic. What you're seeing here in the dark gray is our offshore mean passage. So that's the first metric that we looked at up in this corner here. So the number of birds that passed a 1 kilometer transect over the course of a season. And what you're seeing in the dotted line is the mean for all the radars for each season. So notice that passage of birds is in millions. So while we see that terrestrial migration is higher, when we extrapolate those numbers, again, this is 1 kilometer, these numbers easily become hundreds of millions of birds over the course of the season, even something as small as the spring migration that we see offshore. And I do want to highlight some really, I could talk about each one of these radars. They're so neat. But I want to talk about some patterns in general. We had two radars that showed consistent migration in both seasons offshore. So one is our Corpus Christi radar in on the Gulf of Mexico and Texas. And consistently, we saw a lot of birds in both spring and fall offshore. Also interesting was the Jacksonville radar also saw a decent amount of offshore bird migration. And I want us to think about that when we look at the shape of a coastline here, why that could be and why we're speculating that is. But we do see quite a bit of migration in both seasons at these radars. One of my favorite radars here, the KEVX radar, here right by Tallahassee. We see if you look in the spring, very little migration that we're seeing in the spring for both terrestrial and offshore. But in the fall, we're actually seeing the highest offshore migration of all the radars on average over the 10 years. So there's a lot of things happening at this radar um, that are seasonally different that's happening at this radar. And we believe a lot has to do with a loop migration pattern where birds will travel up in the spring through more of Central America. And then in the fall, they kind of travel a more eastern route as they cross through the Gulf of Mexico. And lastly, I just want to highlight some closer radars to us. Some radars here at KLTX, this number here is about 2,000 birds for on average for the year. Very, very little migration is occurring. However, both of these radars, KTLX and KMHX, in the Carolinas, see this huge uptick also in the fall. Now, this noisy slide is going to tell you what I think I kind of explained in the previous slide, is that in the spring, we don't see a relationship. The relationship we really see, the straight line is indicating that birds are typically going parallel with the coast. So that would be this example here of birds are traveling north to south and pretty much aligning with the coast. However, in the fall, we see a positive relationship with the angle of orientation of a coastline. So as it gets more perpendicular to migration, we see an increase of birds. So that means birds in the fall are more likely to use the offshore environment. And in fact, if we look at this proportion when we compare spring and fall, what this figure here at the bottom is saying is that anything that you see positive is we're seeing a significant, and in dark gray, is a significant difference in the proportion of birds using the offshore environment in the fall. So 10 out of our 16 radars showed this pattern, which also goes to show that there's a huge seasonal component when we think about birds and migration and how they're using the offshore environment. When we look at the rotor swept zone, so these are zones where under 300 meters where birds have the potential to interact with offshore wind turbines. Again, we do see what you're seeing in the light gray bars is a little different now. This is birds above 300 meters versus the number of birds passing below 300 meters in the dark gray. And what we see is there's a lot of variability from radar to radar, but this does occur. And again, in the order of hundreds of millions of birds. But again, a bigger uptick that we see below 300 meters in the fall. So we think of it as there's more migration in the fall occurring, and more of these birds are flying at lower altitudes. Again, another noisy slide that I don't want to present stats too much, but what we're looking at here is, again, the light gray terrestrial, the dark gray offshore, and this dark gray bar is the 90% passage window of how many days, that's on the x-axis, was the 90 percentile of birds traveling, whereas these boxes here represents that moving window of the 25 to 75%. It's a lot to look at here, and I apologize. But the point that I want to make here is when we look at the spring, while we don't see a significant difference in the number of nights that migration occurs for the full migration period, for the peak migration period in the spring, it's about 1 day shorter, which isn't terribly long, but it's still significant because think about we're averaging this across all of the radars. I know I'm getting a little short on time here. We see a more pronounced difference in the duration of migration when we look at the fall and think about we have more birds, there are more birds traveling. So we could see offshore, this is 65 nights for the full duration and versus 71 nights. So we see there's a shorter number of nights occurring there offshore. And also for that moving window of the 25 to 75% peak migration, it's about 4 nights shorter offshore across all of the radars. So that's an important bit of information that offshore wind farm operators would like to know. But what's more pronounced is when we look at the peak number of nights. So remember, migration doesn't occur evenly across the season. We see peaks and valleys of this migration. And the point I want to make here is that even at the 90% passage in the number of nights, what we're seeing here is the violin plots. You can see some outliers here, but these are radars that really don't see too many birds. So the numbers kind of influence the way that violin plot looks. But what I want us to look at is the dashed line is the number of nights on the y-axis for number of nights of migration traffic. The dotted ones are offshore. And you could see in both cases, whether it's the 90% migration traffic or the 50% migration traffic, in spring it is lower offshore, and in the fall, the number of nights is lower offshore. And this is pretty consistent across most radars. And that's really important. We also see this in the fall. So we go from 36 to 43 nights in the 90%, 7 to 11 in the 50% in the spring, and in the fall, 37 to 59, which is a huge difference in terms of the number of nights, and then 7 to 12. So the point being is that this is a really important bit of information that curtailment only needs to occur on a fewer number of nights than what we predict for terrestrial offshore migration. And then lastly, for this study, flight altitudes, irregardless of the season, were always about 13 to 20% lower offshore, which tells us that no matter what the season is, if there are birds migrating offshore, they're typically flying at lower altitudes. So, just to give a quick summary, offshore flights we know are predictable and frequent events. They're hard to study, but radar offers this really great opportunity to do this. Even though offshore migration traffic is lower, due to its vast scale, this represents a large number of birds that are using the offshore environment. There's a lot of seasonality to this migration. We see a lot more birds using the offshore habitat in the fall, which is important for conservation efforts. And the orientation of the coastline seems to be important for these movements. And additionally, fewer peak nights, a shorter duration of the season offshore provides a greater detail of information that we once did not have before. And flight altitudes, regardless of season, are lower. So, if there is a significant overlap between biology and energy production, having these shorter, fewer peak nights is really important in terms of how we implement dynamic conservation efforts. And how we can also reduce operational downtime and costs associated with it. The point of alternative energy is to maximize, or green energy is let's maximize our energy in a way that is also not harming wildlife. And in the future, we're developing these near real-time forecasts in the offshore environment to help inform these decisions in the future. And hopefully, we're using this study to identify times and locations where we can put out fine scale, smaller radars to help and portable, high resolution radars to ground truth these studies. And this work is already being used with and this is really great. The U.S. Fish and Wildlife is kind of leading this with the Bird Collision Prevention Alliance. Um, so part of the coastal offshore lighting work group, I don't know if maybe we think about this with migrating birds, but they're also very attracted to the lighting on cruise ships and freighter ships. And so one of the things that we're trying to implement and to get cruise ships on board is dimming their lights when they're offshore with high migration activity. We're also expanding birdcast to go into the offshore environment. We are still working on this. It's a work in progress, but you can see that we are making progress where we can use essentially weather data to start predicting these movements in near real time. So one last thing, because I know I'm getting close to the end here and I could probably talk about this stuff forever, is I got really lucky with this postdoc and getting to work with some really awesome people. And the radars in Canada are not yet available to the public. They're not online. But I got a chance to do some similar research with Environment and Climate Change Canada. We're still working on this, but I'm going to give us a little sneak peek about some of the research that we're seeing some very different patterns. So I've showed us these double peak migration nights, or I showed you the vertical profile, where we see fewer birds in the atmosphere, and then we see much more birds at lower altitudes. But typically,
Hey, shut up!
sorry. Um, Typically, over the course of an evening, we only see one peak in migration. We only see birds cross a radar once. However, we're seeing this interesting, and what you're seeing here on the y-axis is the number of birds, and you're seeing the course of an evening, a dip. We see a whole bunch of birds taking off, and then we see a whole bunch of birds arriving. We haven't really seen this with our terrestrial radars or with my offshore study work, but I'll show a video of what this looks like. So we're looking at the CAS-MB radar. What you're seeing is birds taking off over the course of the evening and leaving. And then what you're going to see next is this group of birds migrating in and flying into the same coastal area that you saw the birds taking off from earlier in the night. So it's a brand new pattern that we are exploring, and I wish I had more to tell you about it other than we're really excited to be digging into this more and expanding this study into Canada. So with that, I just want to say thank you. I want to thank Benjamin Von Doren, Kyle Horton, Raphael Nussbaumer, and Elliot Miller for helping me learn all the radar things and contributing so much to this work. So thank you so much. And I'm sorry I went a little long. I'm happy to answer any questions.
Shannon, that was terrific. This is Tom Anderson, Communications Director for Connecticut Audubon. I we have a couple of questions, and I have a couple of questions, and I think probably what we should just do is take them in the order in which they popped up. A couple of questions from Michelle Milham, who's a member of ours, lives out east of New Haven. She asked, she says, the radar results are so interesting. Were the seasonal differences and the location specific bird traffic predicted before you did this study?
Can you say that one more time?
Yeah. And Michelle, I'm sure you're still listening. If you could clarify a little bit, maybe, but were the seasonal differences and the location specific bird traffic predicted prior to this study? And I guess what she means was, did was it known to science that these things were happening before you did your work?
Yes and no. Um, Before this work, there was not yet a broad scale geographic study of the patterns. A lot of the data that we have comes from individual nights, from individual ships, and things we know from much smaller scale. And we get a lot of our ideas of how bird migration is happening from what's happening terrestrially. And so while we kind of expected we're going to see more offshore bird migration in the fall, we didn't necessarily know when and where and the timing of it. And now, using this broad scale study, we're hoping that um, resources can now be used in terms of portable marine radars, um, and even putting bioacoustic monitors on platforms and offshore turbines can help us get a better idea of these estimates at a more fine scale. So while we had an idea, we kind of didn't know much about the seasonality specifically at these different radars. Did that answer the question? Sometimes I meander with questions.
Yeah. It answered it for me. Whether it answered it for Michelle or not is a different question. But she had a second question, and it
Sure.
was a much more simple one. I think, does weather during migration impact the altitude of bird
Oh yeah.
migration?
Oh yes.
Yeah.
Um, yeah, for sure. And we've seen examples of this at the McCormick Building in Chicago, where rapid changes of weather cause birds, and with that turbulence, cause birds to drop altitudes very quickly. Yeah, there's definitely this huge component that affects these migratory movements. And that's one of the things that Birdcast and I know Benjamin has been working on this as well, is predicting when these events could seriously impact birds and infrastructure as well. But yeah, that is very much a thing. Things like hurricanes and uh, really intense storm systems, that's when we see things like fallouts that occur, where you have thousands and thousands of birds that are seeking refuge, um, that will fly low or try to find land. Unfortunately, over the water, it's not as an easy solution and not a great outcome for birds when they encounter this.
Yeah. And there are of course plenty of birders who love to go out during a storm to see what might turn up.
I mean, it is a good time to bird. I'm not going to lie, but unfortunately, over the open waters, these birds don't have refuge. So when things like fallout happen, survivorship is not good.
Yeah.
Yeah.
So questions are starting to come in. That's great. So a question from Jenny Aarons, who is uh, a radio producer for Connecticut Public, CT Public. She's listening in tonight, and she asked, who or what organization is funding your research, and have wind farm developers like Ørsted agreed to use info like this and to shut down or freeze their blades on high migration nights?
Excellent question. My research was funded by the Bureau of Ocean Energy Management. It is no longer being funded by the Bureau of Ocean Energy Management and is not at the moment funded. The work I'm doing with offshore wind is being funded right now for Canada with ECCC, so Environment Canada and Climate Change. So I'm not sure what the current situation is, but the funding was through the Bureau of Ocean Energy Management. Um, Ørsted, I have had um, several researchers from there reach out to me regarding the research, but I have not had much follow-up conversation since.
Okay. So our next question, um, are you considering, and this is not from Jenny, this is from somebody else, are you considering basing some radar equipment on offshore wind stations to get more accurate data below 300 meters?
This was something that was discussed, and again, I'm not the one who secures the funding. I'm the one that does the data. This was discussed. I don't know if this is still in the works for the near future, but um, there was talk about bioacoustic monitors and more directed studies in terms of higher resolution radars and potentially thermal imaging. But as far as I know, I have not heard if that is going to be in the near future.
And so a question about why and when birds might be flying into turbine towers. Are birds hitting the turbine towers because they don't see them in the dark? And are they being hit by the spinning blades or flying into the blades when presumably it's more of a risk when the blades are spinning?
So for offshore, we actually don't know if birds are directly interacting with the wind turbines themselves. There's very few that are operational right now. And studying this is really challenging because if a bird was to interact with a wind turbine at night over the water, let's just say there is a collision, it's going to fall right into the sea and be windswept. So the difficulty of studying that is really hard. We know from diurnal birds and terrestrial turbines that this impact, while it could or does occur, it's far less than what we see with other types of energy and collisions and avian mortality.
Okay, so here's a question from Sylvia Halkin, who is I believe, professor emerita, she would be at maybe Central Connecticut State University. She's been a long time Connecticut Audubon member, and she asks, how high up do bad effects of spinning windmill how high up do the bad effects of spinning windmills on birds go compared to the bad effects of non-spinning windmills?
So if a turbine's spinning versus not spinning,
I believe that's what the question is, yeah.
so there's very little. I actually don't know. I don't think there's research that's on that. Are they colliding when they're non-spinning versus if they are spinning? Offshore, again, I don't think we really know. I don't think there's
Yeah. Okay.
any work on that. I'm sorry.
No, that's fine. It may be the answer to the next question too, which is from Ben Oko. Is there data on mortality on land versus mortality in sea?
As of right now, there is almost no data on mortality at sea for migrating birds at night.
Okay.
So we really don't have a baseline. And that's part of where the interest of this study came from, is with the vast amount of ocean and those wind lease and planning areas, where do we put our resources in order to look at this type of mortality? So there really is no baseline there.
Okay.
There's a lot that really needs to be studied, but it's also the same for offshore oil and gas platforms too. And we know that there is mortality associated with it, but we don't know the extent in terms of long term and tons of studies. It's just very challenging.
So it looks like we have two more questions, a few more minutes, so we're in good shape.
Sure,
Is there anything, I'm sorry?
oh, sure, and I'm happy to answer more, and anybody's welcome to email me or
Yeah,
yeah.
okay, great. Terrific. So the next question is there anything visual or audible that can be placed on wind turbines to deter migratory birds? And that actually, the next question is related. The next question is, if birds are attracted to lights, can lights be positioned elsewhere to steer birds away from the collision hazards?
Okay, two great questions. Um, Sorry, the first one was, let me
Or-
just get my
No,
answer.
let me read it again. Is there anything visual or audible that can be placed on wind turbines to deter migratory birds?
So this is something that our working group is thinking about, is are there ways to deter migratory birds if this is occurring? And is that a reasonable solution, whether it's some kind of sound or um, these are just ideas right now. And they're things that we're talking about. We're working with a lighting expert. Are there ways that we can change the light, the kinds of lights? It's very complicated. It's like, how do you reverse that stimuli of birds' attraction to light by replacing it with something else? But also, we have to think about the other animals that are impacted within that immediate environment itself. So, if we implement something that can impact, that we could help deter birds, would that affect something else? So, this is a conversation we're actively having, um, and I think there's a lot of neat stuff coming out in the near future about that.
And the question then about um, if birds are attracted to lights, can lights be positioned to steer birds away from the collision hazards?
So one of the things that the lighting working group is doing right now is working with lighting experts to change the kind of lights that are, for example, on cruise ships, which lights least impact the birds while they're migrating. Aside from dimming the lights, what also has the least impact. So there's a lot of talk about these kinds of actions in the future. But again, it's everything's very brand new. I'm
Okay.
sorry. I feel like I'm getting all these awesome questions. I'm like, we just don't have the answers yet.
That's well, that in itself is useful to know that there's plenty more to learn.
There's a ton more.
The next question is have studies been done on Denmark's offshore wind turbines, presumably studies concerning bird migration and mortality?
Yes. And in fact, there's quite a bit. You said Denmark, right?
Denmark, right,
Yes.
right.
And in fact, and not just
Which oversees Greenland.
yes. Um, what I will say is that there is a tremendous amount of really incredible research, not just in Denmark, but in a lot of Europe in general. I'm trying to be very diplomatic. That is actually being used. They're actually using this research similar to the research I presented. They're actually doing curtailment. We see this in the Red Sea. Maya Broderick, she's doing a lot of the work there and has some really incredible papers where they actually are implementing curtailment. Based
And
on
by curtailment, you mean they're basically shutting down during periods or nights of
they're shutting
big
down
migration.
yep.
Yeah.
Yep, they're shutting down the turbines during peak migration nights, and this is part of ongoing work, but I'm super proud of them for doing that work. It's really incredible, and I hope that that's something we can eventually do here.
Speaking of being diplomatic, I have another question from Jenny Ahrens. Did your funding end in 2025 during the Trump administration?
Yes.
Did. Okay. That answers that.
That's the answer. Yes.
Okay. So let's see. We've got a bunch more here, and I apologize, but I need to get a little bit closer to the screen for me to see these. Again, another question from Sylvia Halkin. Are birds migrating at far higher hertz? Excuse me. Are birds migrating at far higher heights than the windmill blades? Are those birds still at risk from turning windmills on land?
So, and that's a great question. Probably not. And um, we are seeing that birds are migrating a bit higher over land than we do see offshore. And we do see a good amount of migration occurring above 300 meters. So there is a bit of size variation in terms of the turbines themselves and the different models and makes that are done terrestrially versus offshore. Um, Offshore, there's a little bit more variety in terms of the modeling and the models and such. However, most of the birds flying above 300 meters, whether terrestrial or offshore, are out of that windswept zone where you see of the blades. And there doesn't seem, while there is a little bit of impact above that, it doesn't seem to be a collision risk.
So I think this is my question, and maybe it'll be the last. Do we know why birds fly lower over the sea than over land? And presumably some birds migrate over both, if not on the same night, then at least on the same journey. And do they go from if they're flying higher over land, do they then drop down lower when they
Yeah.
hit the sea?
Yeah, there's a couple different, that's a great question. Yeah, there's a couple different studies. That's why we kind of deliberately um, buffered out that coastline effect from terrestrial versus offshore because yes, we do see flight altitudes change between terrestrial and offshore as they encounter a coastline. This is also seen in European studies as well. In terms of why they fly over the water lower, we're not entirely sure why this is, but we do expect that this is occurring on nights where winds are very calm and they can kind of go across the sea in a more consistent airflow that does happen at night offshore when there's not a ton of weather going on. So again, much more to kind of parse out here in the coming years. So if there's anybody interested out there in studying offshore birds, I can tell you at least 6 or 7 different avenues that you can get a PhD or 7 in. So yeah,
Okay.
it's true.
That's great. So before I turn it over to Joyce, I just wanted to remind everybody that I will send the video of this out probably Monday's a day off, technically, probably Tuesday by the time we get it ready. And when we had uh, Emily last week talking about climate change, I was able to take the audio from the recording and use an AI tool from Google called Notebook LM to get a pretty good summary. And I'm going to try the same thing this time as well. I'll run it past Shannon to make sure she's comfortable with the way it summarizes it. But you get both the video and a 4 or 5 paragraph summary of what she said as well. So Joyce, you ready to say goodnight?
Ready to say goodnight. Shannon, thank you so much. Your research is incredibly interesting. It's fascinating that you're leading the way and that there's so much more information that we can be learning. Birds are amazing creatures, and just their ability to migrate at night and manage all of this and understanding it is so important as we move forward. Of course, also when you talk about funding cuts in our State of the Birds, we noted that this is a concern of opportunities for researchers to continue research like this if there are funding cuts. And so we're always going to be working with our partners to look for ways that we can continue these projects. So thank you for being so inspirational. Everyone, thank you for joining us this evening. We did run a little bit over, and I thank you for staying with us and for asking such wonderful questions. And I do hope that you'll continue to join us for our Young, Gifted, and Wild About Birds series, and we hope to see you again on the 26th. In the meantime, have a lovely evening and watch out for your birds.
Thank you for having me.
Thank you.
Thank you.